We are going to compile Godot today
So what?
on Linux
Come on, don't bullshit me.
for C Sharp and enable the double precision. For anyone who's not familiar, double precision instead of floats is basically how you keep your coordinates accurate if you're making like a huge open world type of game. And so basically if you're making Starfield and Godot, you're going to need it. But unfortunately, it's not an option you can just trigger on or off. The engine actually has to be compiled from source to do that. So I'm going to cover that while doing the Linux stuff as well. So we're going to have to kind of, as usual, make sense of the documentation. It's gotten much better than last time I did a compile video, which brings it up to kind of bad. But the information is here. So anyway, so first thing, pretty obvious stuff. Make sure you have Git installed, and then your package manager, it should be the one like here, just Git, and also the .NET SDK. You'll see that here, like you can get the older versions, but just the vanilla one here we see is version 8. So you'll need those installed, obviously, in order to have the C# support. First thing we need to do is clone the repository. So here's the repository. And just for anyone's information, this is the information of the Linux system I'm using. Garuda's Arch-based, but it's got a lot of stuff configured. Like you don't have to configure from the command line and everything, so it's pretty cool. Anyway, so we're going to clone this repository. We're just going to go git clone. I'm in my home directory, by the way. And we're going to specify the branch. So the different versions of Godot, when they're finalized, are set into separate branches here. So 4.2. I'm going to clone 4.2 instead of the latest because I am doing this video for the second time because the latest had a bug in it and it just messed everything up. And this completes because I had this here before, so I'm going to clone it. Okay, so we've got it. Here's the directory, all the stuff in here. This is the repository. So next, we're going to look at the instructions. So there is a page for compiling on Linux, which includes no information about .NET. There's a page on .NET, which, we kind of need both of these, which is annoying, but let's go through it. So the most basic thing here, we have required packages on Linux. I'm on an Arch-based distribution, so I click here and I will get the code. One thing I want to point out is, in my case, I'm not going to install Pulse Audio because it conflicts with Pipewire, I believe it's called. I'm going to show what I mean here. So if I bring up Garuda Assistant here, which helps you configure stuff, so these two don't play well together. I think under the hood, Pipewire is basically Pulse Audio, but it's got a different way of handling devices, something like that I don't even know what I'm talking about. But the point is if you try to install the Pulse Audio package and you have Pipewire, it won't let you, and switching it is a bit messy. However, what I did here is I just put this in and omitted the Pulse Audio package. Everything went okay. So that's what we're going to do. We're going to go sudo, obviously, and then Shift insert will get into most terminals if Control V does not. I'm going to get rid of that last package. That'll screw me up. So this is obviously not going to do much because I've already done it, but that's what you would do to install the dependencies. So next, this is much better than before. So Platform Linux BSD. This one down here is if you're using the Clang compiler. I did get an error with that. So if you want to use that, I should point out they have error somewhere down here. Yeah, this error here. I got this error when I used the Clang compiler, so if you get that, there are some instructions here just in case, but I'm going to just use the vanilla, which is GCC. Now here's the fun part. So if you want to build this for .NET, the information is on the .NET page. So right here, we just need to set module mono enabled equal to yes. It's mono because in their code they say it right here that the mono has not been renamed to .NET everywhere, so that's why it's called that. It's .NET though. So just to enable it, do that, and while otherwise following the instructions for the building the desired Godot. So otherwise following this page, except we're going to add that module. So since I've done the command before, here we have that. Now another thing that is not mentioned here but should be is if you want to compile it with the double precision, you'll see that later in the section regarding the NuGet stuff way down here. So like there's double precision, but you have to do it there, but you also have to do it right here when you're compiling the binary. So we are going to add that as well. Transparency is a double-edged sword. Here you can see it better. Precision equals double. So we'll just go with that. And if you're silly like me and stayed in the home directory, you need to be in the folder where the folder of the repository you clone. So I'm going to do that. Let's just clear this starfish so that way it's clear. So okay, now we're going to execute that command. Okay, so there we're done with the compile. Just about 10 minutes there. So in the repository folder, you'll see this bin for binary directory come up, and it put the executable in there. We're not done, of course. Okay, so you've got the binary compiled. Now we got to come back over to the .NET page, and we need to generate the glue. So since it's painfully obvious what that means, in the Godot repository folder, we have this modules, mono, glue. Essentially what these are files it needs in order to create the final Godot sharp folder. So like the Godot editor itself will generate these, and then we have another step which they give you a Python script down here which will use those and generate the final Godot sharp folder that you need for the C# support, which will go right next to the binary like you see when you download it. So to do that part, again, we're in the repository folder, so we're going to use the Godot binary that we just compiled. So in that bin folder, if you don't get these cool suggestions like the fish terminal is doing for me here, most terminal applications, I believe, you can just type enough to make it unique and then hit tab and it should fill it in. But got this, I've run it before, that's why we have this, of course. So that's the binary that we just compiled. Headless just means it's not going to spin up the GUI itself and then generate model glue. And then this is the folder that's going into, which is the one I just showed. So we're going to go ahead. That's done. It's overwriting, whatever. So the next step is we use those files in order to generate the actual final folder. And that's this building the managed library section. So we just run this, right? No. So this is likely going to be important, particularly if you're running multiple versions of Godot on the same machine. It can get confused. Basically, I think what this is NuGet packages that Godot provides. And I'm not even completely sure, but point being, we're going to create this NuGet source here. By default, you'll just have the website. So we're just creating, kind of like a bucket of NuGet packages, I believe. So NuGet add source, and pay mind to this, the brackets and my local source. As you see up here on Windows, you substitute this in, and on Linux, you substitute this in. Essentially, it's just a folder, which is kind of unclear. So we're going to say home directory, that's what the tilde does, and I'm just going to call it Godot NuGet. That's the folder, and then the name is obviously just the name. So if you end up doing this multiple times and are getting confused on what you have in there, you can remove them. So you can just say .NET NuGet remove source and then just the name of the source. That'll get rid of it. So, and if you lose track of what you've got in there, we're going to look at the home folder, and Control H will show you the hidden. And here, this .NuGet folder, and this NuGet config file, that's going to show you the ones that exist. So here is the one that I just created, and this is the one that always has to be there. It's just NuGet.org. But that's a good way to find out what you have installed. And there'll be a folder corresponding to each one depending on what we specified, right here, this my local source, essentially. Okay, so we've got that. And now in order to incorporate that, this next line is literally just taking this line and adding some arguments here so that it points specifically to this source that we just created for the NuGet packages. This one underneath is literally the same thing as this one, except adding the precision equals double. That's what we want. So I'm going to copy that whole mess. I ran into an error just hitting this copy button. So I'm just going to use Control C, Shift Insert into my terminal, and this my local source. Now, one thing I got tripped up on, you got to be careful here. Don't put the name. You still substitute it like it's a variable here, and put the path. So in this case, again, tilde Godot NuGet. Okay, now that shall have generated the actual files. I'm going to go back here, get rid of the hidden, and go into Godot binary. And there's the Godot sharp folder. That should be what we need to get it running. And again, it's there because we specified the same location here, the output directory. So theoretically, if you were pushing versions somewhere else where you wanted to run it from on your hard drive, you could you could do that if you wanted. So I'm going to click on this and we'll open it up on my wrong monitor as always. So I've created copies of that Final Fantasy project, which I've been using in other tutorials, just so I make sure not to bork one. So we're going to open, actually the copy is for a different purpose. I want to have one specifically for the double precision that we've done, because that is likely to break stuff. So I'm going to go into Godot, blah, 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 this double here. And all this is just a copy of the original project in 4.2. It's nothing different. But we're just going to see what happens. I'll show you what I mean. So I'm going to hit build. And here we go. So looky here. So since this project was built on a build of the engine that did not have that double precision, it's going to throw some errors. So I haven't tried converting it yet. Hopefully you would just have to change variable types. But like this is broken. But the reason I wanted to show that is because that is pretty good evidence that it worked when we put precision equal to double. So this is a build where you can use that double precision. So let's create a new project just to demonstrate that, because I'm just going to delete that anyway, but I wanted to at least make sure we can build a project. Let's hit play, select the current scene as the default scene, and yeah, there it builds successfully. So there we go. There's a double precision Linux C# build of Godot.